Hello primary 4 students, how are you? Welcome in your science class with me, Dr. Shaiba Hamdi Qasim, and your channel, the Big Sister channel. As now, we will study lesson 4 from concept 3, unit 2. So are you ready? Let's start. As we have now lesson 4 from concept 3, unit 2. So don't forget to subscribe, like and share my channel. Here we have activity 8, speed and collisions. We learned before that when the speed of an object increases, so its kinetic energy increases. Also, we know if the force increases of an object, so the kinetic energy increases. As if we push something very hard, so it will move large distance. So this is the meaning of when the force increases for an object, so the kinetic energy increases. Okay, now we will make sure from this information by this experiment, a simple experiment. As we have tools like we need table, we need cardboard, and we need clay. You know the clay that you play with it? Yes, this is the clay that we need in this experiment. This is for studying the effect of the force and speed on the kinetic energy during collision. Okay, so here we will use the cardboard to make a landing platform, as we will put the cardboard on the table, okay? And then we will hold the clay on a distance like 1 meter above the platform, above the cardboard, and then drop the clay lightly, as we will use gentle force, okay, to drop the clay lightly without throwing it very hard, okay? So what will happen to the shape of the clay? We will see that the shape of the clay changes a little and becomes irregular. This an indication that when we use gentle force while we are dropping the clay and the clay collides with the platform, which is the cardboard, what happens? This is collision. So the shape of the clay changes a little. That means there is less damage, okay? We will repeat this step again and again, as we will smoothen the clay, make it round as it was, and repeat this by throwing the ball with gentle force, as more hard than the first one, okay? As first one we drop the clay lightly, here it is gently, okay, as it has more force. So we will observe that the speed will increase for the ball, as when it collides with the cardboard, what happens? The shape of the clay changes more and becomes more irregular. That means that has more damage than the first case, okay? Okay, and then when we repeat it for the third time, we will throw the ball very hard. So we will see that the speed increases and the shape of the clay is completely irregular. So we can conclude here, as the force increases, the speed increases, and that means that the kinetic energy increases, and more damage will happen during collision. So the force increases, the speed increases, the kinetic energy increases, and this is cause more damage during collision. Here we have activity 9, effect of mass on collision. If we have a truck and a car, and both of them moving with the same speed, okay, so we will see that there is a difference between the truck and the car, as the truck has big mass and also has big engine to make the engine that gives the energy to the truck to move. So the truck, as it is a big mass, so it needs more energy and big engine to make it move. Okay, so it has big mass, it has big engine, uses more fuel, okay, and also has more kinetic energy and causes more damage in collision. But if we see here in the car has a small mass, has a small engine, uses less fuel than the truck. Also, it has less kinetic energy that causes less damage during collision. We already know that the kinetic energy depends on the speed and the mass. So if we have two objects that move with the same speed, so we will see the mass. If it is one a truck and the other is car, so that means that the truck has more kinetic energy than the car and causes more damage than the car. And we need some examples for sure to understand this part. Here we have a question like give reasons for. We have two trucks here. One of them has the mass 2 tons and the other is 1 ton. So we have one has large mass and they move with the same speed. Okay, we will notice that the large truck that has mass 2 tons has kinetic energy twice which the small truck has. Okay, as if we need numbers, as here the large truck has 100 unit of the kinetic energy and the other is 50 kinetic. Why? Here this is give reason for question. The truck whose mass is 1 ton has half the kinetic energy of another truck that has mass 2 tons when both of them move at the same speed. The answer here is very simple, as because if the mass of an object increases, its kinetic energy at the same speed also increases. Okay, as the mass increases, so the kinetic energy increases. So this is why the small truck has half kinetic energy of the large truck. To continue understanding this point, we have here what happens if we have a bicycle moving at a speed of 50 km per hour hits a person. So here the person collides with a bicycle. So the bicycle will cause some injuries to the person. What the meaning of injury? To get hurt, okay? And it will cause less damage. This is why, because the bicycle has small mass. Comparing this with a car, as what happens if a car moving at a speed of 50 km per hour hits a person. Here it is the same speed as the bicycle, but here it is a car. It has more mass, so it will cause more damage. So here, when the person is hit by a car, so may this person die, or the life of this person may be endangered, okay, as a car will cause more damage than the bicycle. Okay, so we finish this point. We will study activity 10, energy conversion during collision. We have learned that when two objects collide with each other, so there is a transfer of energy happens and the change in the energy takes place. As we know that the kinetic energy will transfer and some of these kinetic energy will change into another form, sound energy, thermal energy, and so on. As we have an example here, when boys play with these marbles, what happens? As you see here, the kinetic energy transfer from the boy's hand to the marble, okay? And when this marble hits another one, the kinetic energy transfer to the other marble, and so on. Okay? And some of these kinetic energy change into sound as you hear the clicking sound of the marbles. You get it? So, if it's okay, we will study now the Newton's cradle. You know, Newton, this is a name of scientist, okay? And the meaning of cradle, like there are something that rocks or moves left to right, right to left, okay? So this is what the meaning of cradle. Here, as you see, when the man raised up one of the balls in the Newton's cradle, so while it is raised like that, it stores potential energy and it hasn't any kinetic energy. So the ball here has potential energy stored in it, and there is no kinetic energy as it is raised up against the gravitational force. Yes. So when the man leaves this ball, what happens? Yes, it moves in the direction of the other balls, and the potential energy decreases gradually and changing into kinetic energy, as the kinetic energy will transfer from one ball to another. Most of the kinetic energy in the Newton's cradle is transferred from the first ball to the rest of the balls. Okay? So the kinetic energy will transfer from one ball to another until the last ball. It will move outside, okay, as a first ball. And the number of the balls moving in both sides are equal. Okay, as if we raise the one ball, so when the kinetic energy moves through the balls, so the last ball will raised up, okay, only one ball, as it must be the number of the balls moving in both sides are equal. So if we raise the two balls, so what happens? Two balls from the other side will move, okay? What we said, that when we raised up one ball of the Newton's cradle, so it stores potential energy, and when this ball is left, what happens? The potential energy will decrease gradually and the kinetic energy increases, and the kinetic energy will transfer from one ball to other until the last ball in Newton cradle. Okay, and some of this kinetic energy will transform or change into, convert into sound energy. We hear the clicking of the balls. Okay, this is an easy one, that it transform into sound energy. Also, there is thermal energy, comes from the friction between the string and the other balls. You know, the string, that the ball holded by this string. Okay, so the friction between the string and the other parts, and the friction between the balls during the collision. We know friction means when objects rub into each other. So there is friction between the balls, friction between the string and the other parts, and friction between the balls and the air. Okay? Part of the kinetic energy will transform into sound energy and thermal energy, that produced from the friction or rub between the string and the other parts of the Newton's cradle, and the friction between the balls during collision, and there is also friction between the balls and the air. So if you leave the moving balls for a long time, so what happens? The kinetic energy will decrease gradually, okay? And you will see this as the balls on the sides will move less distance. Okay, so the kinetic energy will decrease gradually until after many collisions the kinetic energy becomes zero and it stops. So here we have a very important note that the energy is conserved. Conserve means keep as it is or have the same amount, okay, before the collision and after the collision. So here energy can't be destroyed, energy is conserved, so the amount of energy before the collision equals the amount of energy after collision. And this was the last information in our lesson. So thank you for watching. Don't forget to subscribe, like and share my channel. This was the last video in this term. So good luck. I wish all the best for you. Thank you for watching and goodbye.